Hello guys, this is Zepherus, and today we'll be doing an element collection addition video, where basically I take the additions to my periodic table collection of elements, and walk you through them because I like to do that. But first, I need to tell you about the situation I've got right now. You may notice a change of scenery if you've watched these before. Usually I have the red wall in the background and a white desk. That's because I've had to change location, and that is in turn because of the bees.
Oh, no, not the bees! Not the bees! Ah! Open my eyes!
Exactly. There's, I mentioned briefly in my, things I talk about video, number 2, I mentioned briefly that there are bees in my cavity wall, and today I had the misfortune of noticing they had actually broken through, so I'm not going to risk it, because there's like more than a dozen in there now, and I don't like that kind of stuff, so I'm not going to risk it, and today I'm going to bring you my wonderful ECA from this room. This is, of course, the room from before I actually moved to that room, if that makes sense. There's the original location where I used to do filming, and then there's the location that you're missing out on, which you may recognise from other videos, if that makes sense. Anyway, on to the elementing, because that's a verb now. We've got 3 here. This is thorium, well, at least 2% thorium. It's a TIG welding rod which has 2% thorium in it, and that's one of the main uses of thorium in TIG welding. You don't have to know what TIG welding is, because I don't either. So here we go, a very nice sample. I had this tested, I have all my radioactive ones tested, and it's below background radiation levels. So the radiation from this, because thorium's radioactive, nothing to worry about, so it's fine to eat. Well, probably not, but I'm not going to try it. Yeah, so thorium, named after Thor. It's an actinide on like that bottom level of the periodic table. This is a byproduct of uranium. When uranium does its nuclear things and disintegrates, thorium is one of the things you get out of it, which is a nice thing. It can be used in reactors, and it was also found in 1828, so it's quite a new one in the grand scheme of things. People think that they found it in 1815, but that wasn't an actual element, and they found a real element in 1828 and reused the name, so it's always nice to recycle. So there we go. Let's pick up zirconium next. I'll take it out of its wrapper while I talk. Zirconium is a transition metal, or a transition metal, meaning it occupies kind of like the center bit of the periodic table of elements. As a result, it's quite high density and has a high boiling and melting point. So this is zirconium. The close-up of the sample, because my camera blurs quite a bit. It comes from zircon, which is a mineral which you may have heard of before. You can get crystals and certain rare minerals from zircon, which is nice. It's mainly mined in South Africa and Australia, and is quite strong compared to the other one, which we'll get to in a minute. Its name comes from zargun, which means gold-coloured, which is what zircon kind of looks like. Though this doesn't, obviously, because it's a silver kind of crystalline type thing, because it's a transition metal. Can't really be anything else. It's used in cladding for nuclear reactors, because it absorbs neutrons, which is always a nice thing to have around. And it can also, when it touches water, it disintegrates it. It steals the oxygen, and it turns water into hydrogen, basically, which is nice until you have it in nuclear reactors, as I just mentioned, and you have loads of water flowing around, like Fukushima, for example. Fukushima had loads of water in its nuclear reactor, actually reacted with the zirconium in it, and produced loads of hydrogen. That hydrogen then ignited itself, and burnt quite a lot of people. So, yeah, that is a thing that happens. So, yeah, that's a nice summary of the element. Totally not biased in any way, shape or form, he said, with a grin on his face. Right, let's go on to the next one. The next one is dysprosium. This is also the last one, by the way. Yes, dysprosium, element number 66, the middle one in this case. It's a lanthanide, and it looks quite the same. It is really soft. It can be cut with a normal knife made of steel or stainless steel or whatever the hell you want it to be made out of. Found in 1886 and also makes up the control rods of nuclear reactors. Its name comes from the Greek Dysprositos, I think. Have to check that one. But, yes, Dysprositos, which means kind of like hard to get at, which hints that this element was kind of hard to find, as it was found in 1886, which is the latest of all of these we'll cover today. And it is, in nature, it is never alone. It is always found in compounds, which is probably a good thing because it is quite reactive. And this will slowly react with the air over time and turn kind of into dysprosium oxide, which isn't what I want. But oh well, life's not perfect, as the bees have shown. So there we go, there we've got thorium, dysprosium and zirconium. Hope you like this video. If you have, then thank you. And until next time guys, goodbye.